Hello and welcome to section 2.5. Here are the answers for 2.4. If you have any questions, as always, just let me know. A lot of this was interpreting diagrams and working with those new postulates. And as a geometry student, this is something that you're going to be working with the entire year, is knowing what you can and cannot assume based off pictures. Okay, let's get into section 2.5. We're going to be working with a lot of algebra stuff today, and we're going to be actually starting to prove things today for the first time. Well, I shouldn't say the first time, but we're digging deeper into proofs now. So these are the algebraic properties of equalities. You guys solved equations last year, and you were doing this stuff without actually knowing what you're doing. So these all have properties. They're the properties of equality. And so this is the addition property of equality. And we have the subtraction property of equality. And multiplication, division, substitution. And so basically, when we're solving equations, I will do an example so this makes sense here. What we would do is we would add 2 on both sides. And we have 5x equals negative 3x plus 16. And this was the addition property of equality. And so we're going to be justifying the steps. Everything that we do in geometry, we're going to justify the steps. And then we'd add 3x on both sides. So again, that's the same thing actually, addition property of equality. And then we would divide by 8. So the math here is going to be easy. But we're going to work on, the point of this method, or this section, is to learn how to justify what you're doing and why you're able to do that. So this is the division property of equality. So these are the properties of equality. And then the substitution, I'll do an example of what that is. If A equals B, then you can substitute A in for any B value or vice versa into an equation. And you guys are very familiar with the distributive property. That is another one of our properties of algebra. Okay, here's another example. I'm going to first distribute the, oops, I'm actually going to multiply that by 5. So again, you're going to say, well, this math is pretty easy, right? And that's okay. It's a good way to introduce some properties. So we have the distributive property, add 15, add 15. That is our addition property of equality. And I like to abbreviate, as you can tell here. And then finally divide by 20, divide by 20. X equals, let's see, if I divide by 4, that'd be 8 over 5, 8/5. So division property of equality. And there you go. So that's what you're going to be working on in your homework today, a little bit. This also works, okay, we have 3 other things that work for numbers, segments, and angles. And it works for real numbers. What real numbers are is basically any number that you can think of, both rational or irrational. So any number you guys can come up with so far, unless you know about imaginary numbers, it's a real number. Reflexive just means any number is equal to itself, or the measure of any segment is equal to itself, or the measure of any angle is equal to itself. This seems very trivial right now, but it's going to have purposes later on. So important, oops, that's not a good color. Let's try it right. Okay, so these are going to be important for later on. And then symmetric property, again, these here are, again, seem really trivial. If A equals B, then B equals A. Or if the measure of an angle equals the measure of another angle, then the measure of the second angle equals the measure of the first angle. This is not as important. The symmetric property, not as important. And then we have the transitive property, very important. And when you look at the transitive property, it should look like the law of syllogism. If A equals B and B equals C, then A equals C. If the measure of a segment equals the measure of another segment, and that measure of a segment equals the measure of a third segment, then the measure of the first segment is equal to the measure of the last segment. And that works for angles. So this transitive property is very important. It's going to be used a lot. Okay, so here's a proof. Here's what we're going to be working with, is proving these statements. You're designing a logo to sell daffodils. Use the information given to determine whether EBA is equal to DBC. So EBA is this one right here, and does that equal DBC, this one right there? So are those two angles equal to each other? Now they're always going to give you something. In this case, these little marks here on the 1 and the 3 mean that those are equal. So the measure of angle 1 equals the measure of angle 3, that is given. Okay, now we have EBA equals 3 plus 2. So EBA equals 3 plus 2. Okay, that is the segment addition postulate. The sum of the two small angles equals the full angle. And that's going to come up a lot. Sorry, segment. I said segment. I meant angle addition postulate. That property, angle addition postulate, is going to come up a lot this year. And then EBA equals 1 plus 2. So now we have EBA, this large one, this red one here that I highlighted, equals 1 plus 2, but 1 is right here. So what did we do there? Well, we know that 1 and 3 are the same, so here's our substitution. We're going to take the 3 out and put a 1 there. So instead of saying 3 plus 2, it says 1 plus 2 now, and that's where this statement there comes from. So that is our substitution property of equality. 1 plus 2 equals DBC. All right, let's take a look at that. DBC is right there, and that equals 1 plus 2. Okay, 1 plus 2 is there and there. Okay, that's the angle addition property again. Okay, so 1 plus 2 equals DBC. Now, take a look at these two statements right there. It goes EBA equals 1 plus 2. 1 plus 2 equals DBC. So EBA equals DBC. That is our transitive property, very similar to the law of syllogism that we studied earlier in 2.3. And so we just proved that those two angles are in fact equal to each other. Now this may seem like a lot, and it should, because this is a proof, but we're going to be working with proofs all year, and so we're just going to keep practicing and slowly building on them. All right, and then here's another one. AB equals CD. So that's our given. That's this first statement right there. They're going to give you something. AB equals CD. All right, AC equals AB plus BC. So this is similar to the angle addition, but this is our segment addition postulate. The two smaller segments add up to the full segment there. BD equals BC plus CD. So BD equals BC plus CD. Again, that is our segment addition postulate. The two smaller segments add to the full segment. Now here's an interesting step. They're going to add this BC on both sides. Okay, so we're adding the same value on both sides. That's our addition property of equality. We can always add the same number on both sides. In this case, they are numbers, they're lengths of segments. And then the final step is AC equals BD. So this here, AB plus BC, if you look above, that's AC. So we're replacing this with an AC. And then this CD plus BC, we look above right there, that is really BD. So we're substituting, we're doing a double substitution. We're substituting two different things in. And that shows that AC equals BD. So this segment here is equal to that segment there. And that's another example of a proof using some of the new postulates and properties that we just learned today. Here's the homework assignment. This is going to seem weird, and that's completely normal. Just make sure that you ask questions. There's always going to be proofs in the homework assignments. Make sure you attempt them. Thank you guys for tuning in. Appreciate